Welcome back, students. In this video I will be explaining to you how does down counter work. In our previous videos we have already learned the use of asynchronous up counter and how can we design it. So in this video we will shift to down counters. It means the sequence of the counter would be in decreasing order, and again it will depend on what is the of the counter. So if you look at case number 1, there are two ways actually by which you can create a down counter. So if we compare this diagram with that of up counter, what are the changes you are observing? The change is the output is taken across Q bar instead of Q. So if you will compare this diagram with that of 2-bit up counter, the difference is this one only. The rest, the clock remains same, J and K is connected in a toggle mode, and the output is acting as a clock for the second stage. So all the things are same. What we can see, if suppose the up counter that we have studied in the previous classes, if this is Q1 and Q0 is LSB. Why it is LSB? Because clock pulse is connected to it. So if we say this was an up counter that we have already designed, then what would be Q1 bar and Q0 bar? So these values are obviously the opposite of these two. So it can be 1 1 0 0, and if we do Q0 bar, it is 1 0 1 0. So if we see the sequence of the counting is 3 2 1 0, and the sequence would be repeated. So this is one easy way of creating a down counter. Here what is the difference between up and down? In up counter you are taking output from Q, and if you want to convert the same counter into down counter, simply take output from Q bar instead of Q. So that is what is basically given in case number 1. But there is one more way by which we can create a down counter, and that is basically given in our case number 2. Output is again taken from Q only. Output is taken across Q only, like that of up counter, but the difference lies in the clock. The difference lies here in the clock. If we see our previous circuits, the clock was always coming from Q, while as in this circuit the output is taken from Q as it was for up counter, but the clock pulse that is given to the later stages, it is coming from Q bar. It's coming from Q bar instead of Q. So if we are making this change in the up counter, we can again convert our up counter into down counter. Now first one was very easy to basically guess, because if we are interchanging the values, it is creating a down counter sequence. But if we want to check whether this is acting as a down counter or not, it is better that we shift towards the timing diagram. So again I will start from the pulse, and the basics are now clear, I guess. There are 2 bits. We are creating it for 2 bits. We are creating it for 2 bits only. So it means number of bits n is equal to 2. So the number of flip-flops required are 2, and the number of states are 4. Now it is 0 1 2 3, or is it 3 2 1 0? That we will find out. So let us start with the clock pulse. So we will try to have more than 4, because 4 states are compulsory to show and 2 are the additional I am showing. And again I am moving from 1 to 0, because if you see the diagram, we are following here negative edge triggering. We are following negative edge triggering. So this is my clock. now this clock is given to the first stage here, and this will produce output Q0. We are saying that output is coming from Q0 and Q1 only. So let us draw my output Q0. So Q0 would be like this. We have to basically, you can say, toggle, because if we see our J and K, it is connected to 1. Similarly here, J and K, it is connected to 1. So we are basically in a toggle mode. So we need to change the output, we need to toggle the output, and also the initially we are assuming that flip-flops were reset, they were initially 0. So from 0 you move to 1, then to 0 to 1. So this is what I am doing. I am toggling from 0 to 1, 1 to 0, 0 to 1, 1 to 0, and so on. Now what is different over here is this Q0 is not acting as a clock. This Q0 is not acting as a clock. What is clock for the second stage is basically coming from Q bar. So if this is Q0, what is Q0 bar? Since they are complementary, so we have to simply give a, we have to show a signal that is completely opposite of Q0. Why are we doing it? Because they are complementary. So if this is 0, then Q bar must be 1. So I will write down these values. Now this Q bar is acting as a clock. So and once this clock is given to the second stage, what I will get is the second output Q1. So what I need to do in this diagram is I have to note down where is 1 to 0 transition happening. So while I note it down, this will give me Q1 because Q bar is acting as a clock. And initially the value we are assuming is again 0. So we have to start from 0. Now we are moving from 0 to 1, 1 to 0, and 0 to 1. Okay, now I can note down the value here. Now if I check the output, as I said in the case 2, the output is taken across Q only. The output is taken across Q only. It means my output is determined by Q1 and Q0. Q1 and Q0. So let us check what is the sequence that we are getting. Initially we were assuming that the value was 0 0, as I said here. The value was 0 0 initially. Now if I remove this intermediate signal for some time, now what I am saying is, if I will remove this Q bar, because now I am interested in only my output, I want to check my output, and the output is coming from Q0 and Q1 only. So let us check what is the sequence that is getting created. So so initially we are having 0 0, okay, then we are having 1 1, after that we are having 1 0. I need to, yeah, now it is clear, it is 1 0. After 1 0, in the next clock pulse we are getting 0 1, and then again you are getting 0 0, and then again it is 1 1, it is 1 0, and the process continues. So it is acting as a down counter, 3 2 1 0, then again it is moving like this. So it is a 2-bit asynchronous down counter. So I hope the things are clear. Just to repeat what I said, if you had to create a down counter, there are two things you can do. Either you will keep the circuit same as for the up counter, and you will take outputs from Q bar instead of Q. That is one easy way. And the other way is, what you would do is, the outputs would be again taken from Q only as it was in up counter, but the clock pulse would be given from Q bar instead of Q. And we have seen from the timing diagrams, it is again acting as a down counter. So I hope this topic is clear to all of you. In case you are having some doubts, you can always comment below the video, and I will be very happy to answer your doubts. Keep revising and keep learning. God bless you all. Thank you.